All right, guys, so today we talked about, again, multi-set percent problems, but we talked about percent error. So what is percent error? Okay, percent error is the difference between an estimated number and then the actual number when compared to the actual number expressed in a percent. So it's like when we play these games at fairs or whatever, where we say, ooh, I estimated that there are 580 gumballs in the jar. Okay, we could calculate our percent error by finding the difference between our estimation and how many there were actually in there. Okay, so how to actually calculate it? What we're going to do is we're going to find the absolute value of the estimated amount minus the actual amount. Okay, we're going to put that over the actual amount, and then we're going to set it equal to a percent over 100. So the reason that we're putting our estimated minus actual in our absolute value bars is because sometimes our estimate is going to be below what the actual was, but we still want it to be a whole number, or we still want it to be a positive number. Okay, so you want the difference between the estimated and the actual in absolute value. You want the positive value of that over the actual and set that equal to a percent over 100. So let's take a look at an example. It says George estimates that there were 315 students at a basketball game. The actual number of students at the basketball game was 350. So what was the percent error of his estimate? So set up your proportion. We want the estimated minus actual over the actual. And remember that we're going to write this as part of our work to show the math that we're calculating. So on your work paper, I need to see estimated minus actual over actual and set that equal to a percent over 100. That'll also help you remember when it comes time for a quiz and when it comes time for a test, how to set up this proportion. So write this as part of your work. And then below that, show me your proportion. So we're going to take our estimated minus the actual. So 315 minus 350, and we want the absolute value of that. So that gives us, actually, let's start with our actual because that one's easy to calculate. Our actual is 350, okay? We know that percent's always out of 100, so we put our hundreds right here. Okay, we don't know what our percent is. That's what we're calculating is the percent error. So our percent is going to be a question mark in all of these examples. And then to calculate our estimated minus actual, we're going to take 315 minus 350, and we want the absolute value of that, which is 35. So 315 minus 350, the difference is 35. So now we have a proportion that we know how to solve. We're going to cross multiply 35 times 100. We're going to divide out our 300, and we get that it's a 10% error. Okay, and remember, since we're calculating percent, we have to put a percent sign with our answer. Okay, so let's look at another example. It says, in an experiment, a chemist estimated the amount of liquid in a beaker to be 52 milliliters. The actual amount of liquid in the beaker was 50 milliliters. So what is the percent error? So again, we're going to set up our proportion. We're going to write out what we're doing. We're taking the estimated minus the actual, putting that over the actual, and then we're setting that equal to a percent over 100. So fill in what we know. We know that the actual amount in the beaker was 50 milliliters. Okay. We know that percent's always out of 100, so we can fill in the 100 spot. We know our percent is the question mark because we're calculating the percent error. And we know that the difference between the estimated and the actual is 2. Okay, 52 minus 50 is 2. So that's our difference, and it goes right here. Now we're going to cross multiply. 2 times 100 is 200, and then we're going to divide out our 50, and we get a 4% error. Okay. All right, one more example. Madison estimated that there were 918 jelly beans in a jar. The actual number of jelly beans in the jar was 850. What was the percent error of Madison's estimate? So let's set up our proportion. We have our estimated minus the actual over the actual, and we're going to set that equal to some percent over 100. All right, so let's fill in what we know from our problem. We know that the actual number of jelly beans was 850. We know that this spot right here is always 100 because percent's always out of 100. We know our percent is the question mark because we're calculating the percent error. And we have to figure out that we take our estimated number, which was 918, minus our actual number, which was 850, and we get 68. Okay, now we have a percent proportion. and we can just cross multiply and divide to solve. So we're going to take 68 times 100 and get 6,800, divide out the 850, and we get that it was an 8% error.